Hi guys, so today you're going to learn a little bit about volume. This is something we didn't get a chance to talk about in regular class time, so you're going to lead yourself through some practice today. So volume is part of geometry, just like area is part of geometry. And so let's quickly review what we know about area. So we did a ton of practice. We know that if we have a rectangle or a square, we can easily find the area of this by multiplying our length times our width. And so we know that when we find the area of something, we are finding out how many square units can fit inside of here. So how many little squares would fit inside of this? Now an area refers to a flat surface. So we can find the area of the floor of our classroom. We can find out how much space the floor covers. So we are going to take it to the next level here. We're going to talk about volume. So volume is for a three-dimensional shape. So area is the floor of our classroom. Volume is our entire classroom, including the walls, including the ceiling. It is all the space inside of our classroom. So I'm so artistic and I just drew this beautiful three-dimensional object. And we are going to actually shift our width. Now that it's 3D, the width is actually down here because now we are looking at it from the side. If we have a three-dimensional object and we are talking about our whole classroom, it not only has a length and a width, but now it also has a height. So our classroom is an example of a rectangular prism. Some other examples could be buildings, a box, a cereal box, a fish tank, a card box, this little speaker, a juice box, a tissue box. These are all things that have volume. So volume refers to, you're going to take some notes on your digital agenda here. You have your sentence starter. You have the sentence starter. Volume is, we are going to say volume is the space inside a three-dimensional object. Whoops, that's not how you spell object. So it is the space inside a three-dimensional object. That is what comes after your sentence starter. I'll give you a couple seconds to write this down. Okay, if you need more time, just pause it right here, finish writing, but I'm going to keep talking. So it is all the space inside. So if we were talking like about a cereal box, the volume of the cereal box is how much cereal you can fit inside of that box, how much it can hold. If we're talking about a pool, it is how much water can fit inside of that pool. If we are talking about even a tissue box, it's how many tissues can fit inside of it. So it has to be a shape that holds something inside. That is what volume refers to. Now, if we know how to find the area of a rectangle, we can super easily find the volume of a rectangular prism. The formula just changes a little tiny bit. It's length times width times height. So we're just adding one more part here. So on your handout where it says V equals, it equals length times width times height. So I'm going to give you a couple seconds. Write that volume down on the formula on your paper. And you could also write it very simply here. Volume equals length times width times height. You could write it simply like that too. So we multiply our length times our width times our height, and that tells us how much space is inside of an object. Now, something to keep in mind is when we were doing area, we measured in square units. When we do volume, we measure in cubic units. So it's like how many little cubes could fit inside of a shape. And remember, cubes are three-dimensional. They're not just flat. So it's how many cubes could fit inside. And the way that you'll see, the way that we write cubes is with to the power of 3. So we're going to do a couple example problems so you can see what this looks like in practice. So let me get rid of all this. And let's get rid of this thing here, my ugly drawing. And let's practice. All right, so we have this cute or rectangular prism. Length of 1 foot, width of 1 foot, height of 3 feet. So my formula is length times width times height. And let's apply it here. 1 times 1 times 3. So let's pretend we don't have calculators to use here. 1 times 1 is 1, and then 1 times 3 is 3. This is being measured in feet. And once again, it's cubic feet, so I'm going to put it to the power of 3. So anytime you see something raised to the power of 3, when we're talking like in shapes, that means it's volume. Okay, so 3 cubic feet. Yep. All right, let's try another one. Okay, yes. All right, once again, my volume is length times width times height, and then let's apply it here. Length is 5, width is 3, height is 2. Okay. 5 times 3 is 15. 15 times 2 is 30. So 30, it's being measured in centimeters, so it's centimeters. And it's volume, so it's cubed. Okay? All right, if you want to challenge yourself, you could pause the video here and try to solve it, and then restart the video after you finish solving and check it against what I've done. So volume is length times width times height. My handwriting is getting messier every second. All right, 2 times 1, times 1 times 2. 2 times 1 is 2, and 2 times 2 is 4 meters cubed. All right. So you are going to work through a couple problems on your worksheet, and if you finish early, you can check your answers, and then you could work on this skill on IXL. Nice job.